So we have 5 questions, hopefully get through today. All right, so we need to pick up pace a little bit more than what we did yesterday, but some of the proofs are a bit more quicker. But this one, D, will be probably the most substantial of the proofs. Okay, so we've got AB, which is a diameter, and AP and AQ are 2 chords which cut the tangent at B in X and Y. So as you're reading through the question, you are making sure all that information is there. Okay, now you're told that the 2 chords, you're not told the 2 chords are equal. Okay, so even though they appear equal in the diagram, you cannot assume that they are. Okay, only if you are told that they are equal, you can use that property for whatever part of your proof. So we are required to show that PX, YQ is a cyclic quadrilateral. So what we need to do first is we need to put in PQ. Let's put the whole thing in there. Alright, so we need to show that PXYQ, that forms a cyclic quadrilateral. Okay, so there will be questions where you're asked to do something in terms of cyclic quadrilateral and it's not in the circle. Okay, because if I were to draw a circle of certain sides and certain centre point, okay, then those 4 points will be on the circumference. Okay, so we need to be able to do that. So the overall big picture, what am I going to aim to show? Thinking about your cyclic quadrilateral property. Yes, okay, the opposite angles are supplementary. So if I show this angle is supplementary to that angle, and this angle is supplementary to the angle at the top, then that will be a cyclic quadrilateral. Okay, so that's the overall result. Alright, so that's right, PQ is produced. Okay, so that means that line I've just drawn there, I've produced that. Alright, and I'm going to start here, X and Y. So angle Q, let angle Q AB is X and angle PAB is equal to Y. Okay, so again, we cannot assume those 2 triangles are the same. We cannot assume those 2 angles are the same. So until we can find the evidence to justify that, okay, we need to notate them separate letters. Alright, what can I do? Say again, sorry?
So like the angles are like at Q inside, so where X is opposite X, you can put in those.
Which one? This one?
Yeah, because they're all the right angle triangle.
How do you know it's a right angle triangle? Okay, now, it is a right angle triangle here, okay, as well as here. What is the description to be able to state that it is a right angle triangle? Well, what's this? What do we call that part of the circle? Chord. What's this part of the circle? A chord, which is specifically a diameter. Okay, what happens when you had a line from the centre that goes to a chord? Yeah. Okay, so a line from the centre to a chord will bisect the chord. What that will mean is these 2 chords are equal. Okay, and also bisect means cuts in half, because it cuts in a straight line, means those two will be right angles. Oh. I've just worked out a much easier way to prove it than what I did yesterday. Alright. So, angle, what are we going to call that letter? Well, it's not the centre, isn't it? Is it notated in diagram? A, P, Q, let's call it R. Capital R. Alright. So angle A, R, Q is equal to angle A, R, P, which is 90 degrees. Okay, so line from centre to chord will bisect. Bisect chord. Actually, no. No, back to my original proof. Alright. Right, what else can I state?
The angle of the ear from where R is the angle QRB.
Q, hang on, QRB. Yep.
And BR.
Yep, it's also 90, okay. But before we state that, anything else we can show or show? Hey. AQR. Yep, we can do that. Do I do that one? Nope. Okay, we can state that, of course, but we don't actually need it. Well, what's XY? What part of the circle is XY? Well, how many places does it touch the circle? XY, what we call that?
Oh, that XY.
Yeah, I was looking at X, Y, Z.
Oh, sorry, the interval XY. Sorry, not the angle XY. Sorry. Is a what? Tangent. Alright, so what can you tell me about the angle RBY?
90 degrees.
90 degrees. So angle RBY is equal to angle RBX, which is 90 degrees. Alright, the reason, radius is perpendicular to tangent. Okay, so where I was going was we can then justify that these two are parallel because the corresponding angles are equal. However, when I go to co-interior angle, that'll make these two supplementary, but I want those two supplementary. Alright, so we'll take just probably about as much work anyway. Alright, well, looking at triangle ABY, alright, you should be able to tell me in terms of x what the angle AYB equals. Yes, so the whole triangle here. Okay, so we've got x down here, we've got a 90-degree angle, so what's an expression for the angle up here? And then minus 90 as well. Yep, okay, so angle AYB is going to be 180 take away 90, the sum of the other two sides. Okay, so you either need to say take away 90, take away x, or you have take away and in brackets the sum of the other two angles. Okay, which will equal 90 take away x. And now we can see why we need to make these diagrams nice and big. Okay, so you can actually put this information in there and see how things are going. Alright, so we need to state a reason. Angle sum of triangle is supplementary. Okay, so we'll focus on that top triangle for now, on x's, and then we'll see what we can do with y. What else can I do?
A and B, 180 take away 90.
That was my original thought, before anything was on there.
Mm-hmm. Alright, let's go to manage chain of thought. QB is produced. Okay, the angle AQB is 90 degrees. Why?
Angle in a semicircle is 90 degrees.
Good. Right. So can we now see trivially that this is also going to be a right angle here? Okay, because the angle is on a straight line. Right. Now, can you all now see that there is a triangle QYB with two known angle sides, and we can get the other one now? In other words, the angle down here. So what's the angle YBQ in terms of x? Well, what's the maths I need to do? Angle YBQ can be 180 take away 90 take away x. Hang on. Okay, and we need to add that 90 degrees. Okay, so this is the other two angles. We've got 90 take away x. You have the 90 degrees here to find the value of that angle there. Alright, so we've got 180 take away. So we've got 90 plus 90. 180 take away x. They'll cancel. 180 take away 180. And then negative, negative x. That means that angle here will be x. Nope, I've lost people. Mikhail gave a funny face, so I'm assuming she didn't follow. Anyone else did not follow? Okay, so we've gone and stated this was the right angle. We've already justified that this is 90 take away x. So if we do the angle sum of a triangle, that triangle here, alright, I'll be able to find the size of this angle in terms of x. Okay, so we did 180, take away the sum of the other two angles. And then after simplification and expanding, I'll get left with the expression x. Alright, so the reason why I'm doing that is because we need this angle here for the cyclic quad. I know that this part of it here is 90. I need an expression for this part here so I'll get the overall size of that angle there. So, what is angle RQB going to be?
Wait, there's like a really, really big film you could do to like show that, but it's really long.
Well, there's something
So
actually
it'll be like,
straightforward.
RQB equals
not
X.
offset. No, it'll be,
RQB equals X because parallel lines.
Yeah, okay, so because we've got the right angles here and here, can everyone see that line will be the two parallel line and here they are transversal? Okay, so these two corresponding angles are equal, therefore QR must be parallel to YB. Yep. Right, so let's write something in the... So since angle ARQ is equal to angle ABY, right, which will imply that RQ is parallel to BY. So reason corresponding okay, so we need to make a statement regarding why those two lines are parallel first before we can state what Robin has determined the value for that size. Right, so as you're proving each of your thing, right, you need to incorporate those into your diagram. Okay, so we just proved those two lines are parallel, so let's put parallel symbols on them. Alright, so therefore this angle here must be X because these two are parallel. There's the other transversal that you can use. There's another transversal up that way you can use. Okay, but because of the alternate angle, these two angles here must also be equal. So we got angle RQB is also X. Alternate angles on parallel lines are equal. Alright, so that now means that angle YQB, YQR, okay, can be 90 plus X. Okay, YQR, so therefore angle YQR is going to be 90 plus X. Alright, are there any questions so far before we move on to the next bit? Is everyone following somewhat what we're doing here? Right. So, we've found the value of the top two in terms of the pronumeral that we've already set. Okay, we found the value for the top two angles. We need to now find the value for the bottom two angles. Can everyone see that it's going to be pretty much the same proof again? Alright, you are not required to do it again. Alright, because of the same structure, and you can recognise pattern, Okay, all we need to do here is say similarly. Okay, so if this was 90, take away the variable here, the angle down here is going to be 90, take away that variable there. Okay, the angle BXA is going to be 90, take away Y, and angle XPR is going to be 90 plus X. Sorry, plus Y. Alright, because that'll be the same proof, pretty much that way through. Alright, so 90 take away Y here. And this whole angle here, so we need to notate the arcs, is 90 plus Y. Okay, and this is why your diagrams need to be fairly big so you can label these things on it as you go. Alright, so now we need to show that 90 take away Y plus 90 plus X equals 180. And we also need to show that 90 plus Y plus 90 take away X is also 180 degrees. If we are able to show that, then we have supplementary, opposite angle supplementary, which will mean P, X, Y, Q is a cyclic quadrant. Right, how?
Does it involve two equations? Substitution.
There's a more simple way to do it, Robin.
That's what exactly it is.
Working out the 90 plus Y and 90 minus X equals.
Right, do we notice anything about triangle ARQ and triangle ARP? So,
Oh, they're the same triangle.
they're congruent triangles, aren't they?
That's the word. Yeah,
Why?
Angle, side angle, side.
Side angle side. Both these are right angles. We have equal chords here from that first property. We also have a common side there. All right, and then matching your congruent angle sides, that means these two angles will be equal. So what we can do is then substitute for the variable and only deal with one variable. Okay, now, I had a bit of a discussion with Mr. Smith about this. If it was just a general 2-unit congruent triangle proof, okay, you can make the statement, these two triangles are congruent because of this property. Okay, however, because we've had to use an extension 1 property with the circle geometry to say these two chords are equal, that means you need to state that in your part of your proof as well. Okay, so, but the good news for you guys is you've already stated that. Okay, the line from centre to the chord bisects the chord. So let's label that back up there, way back up there, that property, number 1. Okay, because that gives you two properties that you need for your congruent triangles. So, right, so from 1 and the fact that A R, was it? Is common. That which will imply that triangle ARQ is congruent to triangle ARP. Alright, side, angle, side. Alright, so because we're doing a circle geometry question, the markers are not necessarily marking on a congruence proof. Okay, they're marking on your showing that it's a cyclic quad. Alright, which also implies that x is equal to y. So, next bit, if P, X, Y, Q is a cyclic quad, right, this must mean that 90 take away X, okay, so the angle at the top, this angle, and the opposite angle, 90 plus Y. So we add 90 plus y must equal 180. Okay, so you're stating the property of a cyclic quadrilateral, you're now proving it. Okay, so let's label this equation too, x equals y. So using number 2, so we have 90 take away x plus 90 plus x must equal 180. Alright, and good thing, because the x is now cancelled. 90 plus 90. Okay, so 180 equals 180. We have a true equation. And similarly, for I probably should have stayed on angles. And similarly for angle RPX and angle, angle YQR. YQR plus angle YQR and PXB. Therefore, opposite angle of PXYQ are supplementary. Okay, which implies that PXYQ is a cyclic quad. Alright, so the reality is there will be some circle geometry questions that will take a bit of time. Okay, but nothing in that was particularly hard. Alright, it was just a few concepts you had to put together to show. Alright, so that would probably be one of the more longer questions I've ever done. Okay, questions don't usually take that long. Okay, questions are more often more simple to show. Okay, do we all got an understanding of what's going on there? Yep. Alright, let's try the next one. Something back a bit more simple now. Alright. Then, now we're up to E. Alright, A, B, C, F, E, D. We had the parallel side AD and CF. Showing the question. In the figure, AD is parallel to CF and ABC is a straight line. We're good? Alright, you will notice as well in the diagram that one circle, the circle on the left, sorry, looks slightly bigger than the circle on the right.
Is it actually?
Well, it looks that way, so I'm going to redraw it that way. Okay? I don't actually know. Okay, and it's not part of our proof anyway. Alright, so we've got the angle X, the angle W, we have Y, and we have Z. Right, so we need to show that DEF is collinear. So what's collinear mean? Forms a straight line. Okay? So let's write next to it, collinear mean in a straight line. Right, so we need to show that DEF is collinear. So, the overall picture, what do we need to show? In order that DE and F are collinear, we need to show that, what?
180 degrees.
What's 180 degrees?
All three of those, two of those.
Down the bottom here, so what's the expression we're looking for? W plus Y equals 180. Okay, so when we have W plus Y is 180, we can then show, then we'll be have enough to say that DEF are collinear. Right, what can we state? So you've got variables already given there. What can we state?
180k by x.
Yes? We can state that. However, again, it's going to take another couple of lines of working to what we need to do. So let's spend an extra 10 seconds thinking about the question, what information is given to you, and see if we can simplify things a bit more. Okay, so McColl's on the correct path, saying that 180 take away W is equal to X because it's a cyclic quad. But there is another property involving cyclic quads that you can have a more simple expression. Y. Yep, correct. Y. Exterior. Okay, so the interior and the opposite exterior angle are equal in the cyclic quad. So X equals Y. Exterior angle result. What else? Okay. W equals Z. Okay, as above. Alright, so what else can we state? So we have cyclic quadrilaterals. What else do we have in our diagram? So what can we state involving parallel line?
X plus z equals 180.
Yep. So X plus Z is equal to 180. Co-interior. Okay, co-interior angles are not equal. Alright, they are supplementary. The only way they are equal is they are both 90 degrees. Probably should have said at the start, we need to show that W plus Y is equal to 180. Okay, so that's what we're getting at. So do I have enough there to be able to finish the proof? Okay, because x is the same as y and z is the same as w. Okay, so now I have enough to state the proof. So let's say 1, 2. So from 1 and 2, we have that w plus z is equal to 180 degrees. Okay, which implies that D, E, F is a straight line because at the vertex at E it is straight. Okay, and that means D, E and F are double L? Yeah, co-linear. Now if you write it with a single L, I don't think that will punish you. Okay, I certainly won't. Okay, so often like this, they can be straightforward, only a couple of lines and you're pretty much done, okay? So, I don't want to scare you with the previous question, but yeah, I'll have to give you reality that sometimes they will take a fair bit of working to get through. Right, question? How are we feeling about circle geometry now? Alright?
Oh, no.
Alright, let's have a look at this one.
That was pretty wacky.
Alright, A, D.
Is this one going to take a lot of work?
Nope.
No, no need.
That's the thing. Some questions look complicated in their diagram, but are actually straightforward once you get started. Okay? Oops, I forgot one line. There's Y there, X here, Z here, and we also have that whole angle here is Y as well. Okay, which you should be able to say Y.
This one won't matter. It won't matter.
Alright, so the question reads, AB and CD are perpendicular chords. AB, CD perpendicular. If you're not given the right angle already, put the right angle in there. Okay, of a circle with centre O, we need to show, prove that angle DAB, which is X, is equal to angle OAC. So in other words, X equals Y. Alright? Right, so you probably should start the following. So we need to show that X is equal to Y. Okay, because they're the angles that were notated in the notes. Right, that's the whole proof. Okay, so because a diagram looks complicated, doesn't mean it will be. OAC. Right, let's go. How are we going to prove it? Alright, x plus z is going to equal 180, take away 90, y. Okay, angle sum of triangle. So x plus z plus 90 must equal 180. So if x plus z must equal 180, take away that right angle. Angle sum of triangle is supplementary. Alright, let angle ABC, let it be equal to z at the circumference. Alright, where would I go next?
I know what we're doing. Angle COA equals 2z.
Good. Okay. Radius, radius, common point, chord, chord. Angle at the centre is twice the angle at the circumference.
Y plus z is going to equal 180.
Almost, not quite.
No, 90.
Yes. Alright, so angle COA is going to be 2z. Okay, the angle at centre is twice angle at circumference. So even if you don't get that far in your proof, you should be able to get your part marks at least. This question is worth 2, maybe 3, and you can state one of your properties. That might be enough to get 1 mark. Okay, so if you can get started on these questions, and then hopefully you can get it done once you get started and get a bit of momentum. Otherwise, if we can't get the final proof, at least write down everything you can that you can show, and that may be enough to get it. Alright, so we have 2z plus 2y is equal to 180. So we're looking at triangle COA.
It's so unnecessary. Z plus 2y equals 180. So then z plus y equals 90. And then there you go. X equals y. That's it.
Yeah.
That's it.
Now I just looked at my diagram. I shouldn't have let z equals that because I've already got that variable, but lucky because of the butterfly wing, they are equal. Alright, so don't do that. Angles in the same segment are equal. So alright, so that means Z, sorry, we've got to give the reason for that first. Angle sum of triangle is supplementary. Alright, so that will mean Z plus, Y is equal to 90. Go back up the top, equation 1. Equation 2, and they're both equal to the same number. Okay, so both x plus z and z plus y equals 90. So from 1 and 2, we have x plus z is equal to z plus y. And the z's cancel, so x is equal to y. Alright, and then your last line needs to be angle OAC. Alright, so because you are proving, so like in your English essay, alright, when you are writing essay, you need introduction, you need your body, and you need your conclusion. Same thing with these sort of things in math, okay? You need your introduction, your body, and your conclusion. In about a 20th of the time it should take for the essay. Alright, now the next two are fairly quick. Alright, so we can try and get through these. So you are got some cover ready for your assessment. Are there any questions on this question? Everyone's okay? Alright, let's try the next one. G. What you need to ensure when you are reading through the question that all that information is in the diagram. Okay? So, given AB equals AC, so they won't always tell you these things, like show these things on the diagram, or things that are on the diagram will not be told to you in the question. Okay? So as you are reading through the question, you need to incorporate that information in the diagram when it's not there. So AB equals AC, and XAY is the tangent to the circle at A. We need to prove that BC is parallel to X. BC is parallel to XAY. Alright, big picture. How are we going to show those two lines are parallel? Okay. More than one way we can get the answer. But I'm thinking that's going to be more of a process than something that's going to be much more simple. Now I'm going to show that these two lines are parallel.
Yeah, show the
Alternate angles, okay?
Carlos on that.
So Z here, or a Z here. If we show that they are equal, those angles, okay, we can have the parallel line. Right, so where we'd like to start, up the top or down the bottom? Up the top, so let's call it X. So show, here's my introduction, that let angle XAB is equal to X. So what else can we state from that? What other angle in the diagram, sorry, can I state relating to X? A, B, C?
No.
Can we?
No.
Not yet.
We want to, but we don't.
We want to, we will get there, but we need to do something first.
Is A, B, C equal to X because the interior opposite angle is equal?
No, but that's
Say it again.
You can just say that.
No, we don't know the power.
We don't know they're parallel.
No. The angle in alternate segment was the exterior angle.
This one, you mean?
Yeah.
Yes. So, tangent. Whenever you see a tangent and a chord, like I said, you are going to come up with this property more often than not. Okay? Angle between a chord and a tangent is equal to the angle in the alternate segment. Okay? Angle ACB is equal to X. So angle between chord and tangent is equal to angle in alternate segment.
Now,
And it's the same on the other side.
oh wait, no, it says
Yes, get in there. A, B, C is equal to X. Reason, base angles of isosceles triangle are equal. Okay, since angle XAB equals angle ABC. Okay, so XAB is equal to angle ABC. Okay, which implies that BC must be parallel to XAY. Alternate angle on parallel lines are equal. Okay, so introduction, the body, and the conclusion. Okay, nice and simple. Okay, any questions on that one? Alright, can I go another 5 minutes and get the last one done?
Yeah.
Probably started about 5 minutes late anyway. Alright. Wowzers, let's go. Again, it looks like a complicated diagram, however, the solution is pretty much, very straightforward. It actually took me 2 goes to do this question, and I realised, how did I miss that? Alright, so even gets the best of us sometimes. It's good to see a few people have done their homework and a few people haven't. Even I asked you very nicely last night. You didn't need to reply, you just need to do it. Okay, so DG is a tangent to the circle at D. Okay, so the tangent here is the tangent there. Okay, so what are we thinking when we say tangents and chords? Okay, automatically thinking those things. GABF and DCF are straight line. GABF and DCF straight line. Alright, we need to prove, so we need to show that 2 lots of the angle at ADG is equal to angle Beck plus angle BFG, BFC. Alright, the 2 lots angle ADG, the 2 lots of that one here is equal to angle BEC, that angle there, and angle BFC, this angle here. So they're not equal necessarily, so we need to put different markings there. Alright, where am I going to start and what am I going to state for my first property? I just said it about a minute ago. Alright, let this one be X. Alright. So what else can we state? So? Which angle? ECD, yep. What we have here is tangent, the chord. We form a triangle using that chord here. That means this angle here will be x.
And then ABE is going to equal x also.
Right, let's start with the first one first. So angle, so angle ACD is also equal to x. So angle between chord and tangent is equal to angle in alternate segment. Now, Michaela has noticed that this angle up here is also x. Alright, now, because of the butterfly wings, also angle between a chord and a tangent, you can form the triangle up here as well. Yep. Okay, you can form that top triangle. That means those two angles will be equal as well. Angle between the chord and the tangent. Okay, so what we've done with the bottom triangle here, there, we can also do the same for the top triangle because they still have that common chord there. Okay, so I'm just stating that that's another way you can show that is x as well. Right, angle A, angle AB is also x. Okay, so you can either state as above or angles in the same segment are equal. Okay, it's much quicker to write, so I'm going to write that one. Right, what can I do now? What could I possibly do right now? What could I do? Anything at all? What can I do? Anything at all?
The ECF equals 180
B, what?
ECF.
BCF.
ECF.
ECF, yep.
Equals 181.
Good. Yep. Angle straight line. Supplementary. Alright, so that means this must also be the same. As above. What can I do now?
Right, yeah. What Carl said.
Hey,
Draw line through the
don't need to. What were we required to show? That and that plus that must equal two lots of that.
So it's going to be at 180 plus x, 180 plus x. They cancel out over 2x.
On the right track, yes. So, alright, so angle BEC plus angle BFC, so the two angles that were notated with the arcs, okay. Can we see that it is a, BECF is a quadrilateral? What's the angle sum of the quadrilateral? Any quadrilateral is 360 is equal to 360 take away 2 lots of 180 take away x. Alright, 360 take away the sum of these two angles will give us the sum of the other two angles. Okay, so that's why there's a 2 out there. Right, let's expand. 360 take away 360 plus 2x. Looking good? Okay, which equals 2x, which equals 2 lots of angle ADG. Okay, that's it. Alright, you have now done, not done, you have witnessed 8 circle geometry questions. Alright, and there's probably a good mix of questions in terms of how simple they can be and also where you could expect how hard they could be. Okay, so you now have the rest of chapter 9 task to do, and here is your past HSC assignment, which is every single question from 2001 to last year's exam, 2014. Every single question. Because every single HSC you will have a circle geometry question, okay? Now, lucky for you as well, in your HSC course, you will do this again, not the individual properties, you will do more the proofs, okay? But we're getting started now because I didn't do the proofs with Matt and Cooper last time in the prelim course. We just did the property, okay? But if I had done the proof and then they do it again in year 12, they would have been a lot more familiar with what's going on, okay? Right, so your task will not be due any earlier than when your assessment's due, when you are sitting your assessment. Okay, so you've got a couple of weeks now. That means the next week will be 2 working lessons because I've covered everything for the theory, that you'll have a chance to get some work done, ask questions, ready for your assessment. Okay?